This is Mr. Beck Does Your Homework, AP Physics, Homework 7.2, questions 16 and 17. A beaker of mass 1.3 kilograms, so this is 1.3 kilograms, containing 2.8 kilograms of water, so this is 2.8 kilograms, rests on a scale. A 3.8 kilogram block of a metallic alloy is suspended in a spring scale and is submerged in the water as shown in the figure. What does the hanging scale read? So what's happening on this hanging scale is I have this 3.8 kilograms that's hanging down. I know the density of it, and I know the mass of it, and this scale, what this scale is going to read is the normal force, is going to be the tension in the rope. And this weight is at equilibrium, so it is going to have a balanced set of forces. So on that hanging mass, I've got a tension from the spring scale, I have a buoyant force from the water, and I have a force of gravity. So those three all together are going to combine and be equal. I don't have to worry about the weight of the water or the weight of the thing, so this is just what I'm looking for. So I'm looking for, what does the hanging scale read? That's this one. So I've got buoyant force and gravity I've got to deal with. So I know that force tension plus force buoyant equals force gravity. I'm looking for force tension, so my force tension is going to equal my force gravity minus my force buoyant. My force gravity is going to be the mass of the object times the acceleration of gravity, so that's going to be 3.8 kilograms times 9.8. My buoyant force is going to be the density of the water times the volume of the object times the acceleration of gravity. So the density of water is 1,000. Oh, sorry, this is minus. Minus 1,000 is my density of water times my volume of the object. Okay, let's see what the volume of the object is. I know the density is 4,900. I know the mass is 3.8. And I know that density equals mass divided by volume. So my volume is going to be my mass divided by my density. So this is going to be the mass of 3.8 divided by the density of 4,900. And then that's times g of 9.8 as well. So this is going to be my force of tension. This is going to be the reading on the scale. I've got gravity pulling down, the buoyant force pushing up. That's going to give me my force of tension. So that's what the hanging scale reads. Now, what does the lower scale read? Well, I could do some fancy things here, but I know that this lower scale is pushing up, this scale is pulling up, so I can just picture this as one big black box in here. And I know that the total of everything in there is the mass of the water, which is 2.8, the mass of the thing, which is 1.3, and the mass of this is 3.8. So all of that is inside, is in this box that I just drew. But up here, it's pulling up. So I've got to minus my force of tension that's pulling up. And that's going to equal what the bottom scale weighs. Actually, this is all mass, so I'm going to have to multiply that by gravity. So that's a force minus a force is going to give me the force on the bottom scale. And that's what the bottom scale will read.